Talk about question number 3 of AP Physics C 2024 Mechanics Solution Set 2. There's a uniform disk of radius r and the mass md is attached to the vertical pole by a horizontal axle that passes through the center of the disk. So here we have an axle and this is the vertical pole. Friction between the axle and the disc is negligible, and a lump of clay of mass m sub c is attached to the edge of the disc at point A. The size of the lump of the clay is small compared with the radius of the disc. Okay, so it can be considered as a point mass. That's what they meant. A horizontal string is connected to the pole to the edge of the disc at point A. So this is the string. String makes an angle of theta with the line between a point A and axle is shown over here. So on the following representation of the clay disk system, draw and label the external forces, not components, exerted on the system. Okay, each force must be represented by a distinct arrow that starts on and points away from. So this point is the point where the clay has been kept. So we need to find the forces over here. So I know that the first force is definitely, and by the way, we need to show the forces on the system, not only at point A, right? So first, let's talk about the sphere. I think the sphere, there is only one force which is acting at the center. Um, Let me just take the situation over on the next slide so that I don't have to do this again and again. So what I'm saying is there is definitely a force which is acting over here, right? Which is mg, because that is the center. So mass of the sphere, which is m sub d times the g. This is the sphere, right? And this is what we have. Oh, sorry, this is a disk. It's not a sphere. So anyway, but md is what is the mass of this, and the force is going to act downwards. Likewise, for point A, there will be mass of the clay, which is represented by f sub c times g. Because of the string, there will be a force over here. After the string, there will be a force over here, which is represented by tension. But since this string is connected at this point as well, so don't you think there will be a tension over on the right side over? But okay, that will be the tension on the rod, right? We are not interested in the rod. We are just interested in the disc and the point on the clay. So clay, obviously, two forces. I don't see any other force. Disc, one force. But I think there should be another force. You know what? There should be another force, because it doesn't make any sense right now, because there are two forces which are going downwards on the system, and there's one force which is going to the left. So as of now, the forces are downwards and to the left, but the system is at rest, so obviously the net force should be 0. So there should be a force because of this pivot, right? Because of this pivot, because, or axle, you can call it as axle, which should point in an oblique sense, so that it can have one component over on the right side and one component over at the top, so that it can counter these two. Sorry, this can counter this one, and the right can counter left one. So how am I going to show this? I think I can just show in a slant fashion. So I will just show it like this, and this will be f of the axle. This is what we have as the complete free body diagram. The next question which we have is, derive an expression for the tension in the spring when the clay is at point A in terms of this and the physical constant. Okay, so let's see. When the clay is at point A in shown. Okay, the figure 2 is not a part of it, so let me remove. So I think I'm going to borrow this figure. This is going to be helpful for me. Both of these figures. Let me just borrow. Why is this helpful? Because I'm going to now conserve the torque about the axle. No, sorry, not the conserve. I'm going to say that the net torque about the axle is going to be 0. Why is going to be 0? Because It's in static equilibrium. So since this is a question of static equilibrium, at any point the torque is zero, but I'm going to choose the point of axle because I don't know the force of the axle in the first place, right? So if I choose any other point, it won't make sense because will not be able to solve it. I don't know the force of axle because that will start exerting torque. But if I choose this point, the torque by the forces acting at this point is just going to be zero. So I don't have to worry about that. So the only two forces which are exerting torque are these two. So let's find the torque. So this is the first force which is trying to exert the torque in the counterclockwise sense, and the mg is over here, which is trying to exert torque in the clockwise sense. So obviously these two should be equal and opposite. What is the torque due to the tension? It's going to be F of tension multiplied with RF sine theta, right? After all, this is what we are talking about. And the net torque is zero. Torque is given by RF sine theta. So what is R? R is just capital R. F is Ft, and sine of theta is just sine of theta because the angle is theta. And this should be equal to the other one, which is going to be again RF sine theta. R is once again, I think R. F is mg, and what is cos of theta? Now theta is this one, which is 90 minus theta, the angle. So it will be sine of 90 minus theta. I believe R and R is gone from here, and I need to find Ft. So let's divide both sides. First off, let's redecorate this a little bit because I know that sine of 90 minus theta is going to be cosine of theta. So this will be mg cosine of theta, and then dividing both sides with sine theta, this will become mg cosine of theta over sine of theta. Obviously, cos of theta over sine of theta can be written as cot of theta or cotangent of theta. So this is the final answer, or this is also the final answer. Right. Next one talks about the string remains connected to the edge of the disk at point A. The clay is moved to point B, but okay, the clay has been moved to B, which is horizontally in line with the axle. So how does the new tension compare with the tension Ft as shown over here? Okay, all right. So they are just suggesting that the tension is still over here, but the torque, the clay has been moved to position B. So I think the Ft, which will still be acting over here, which is going to be Ft new, let's call it Ft sub n, and mg is going to mcg is going to act over here, and these two things are not going to change. We are not even bothered about this because this is our axle as well as the point about which the net torque we are taking as zero. So how will the equation change? And by the way, this theta is still theta, right? I'm just going to erase these two forces because they don't have any job here. Uh, the theta is, what was theta again? Yeah, this was theta. The theta still remains the same. And this is still R. This is also R. So how will the net torque look like? It will look like Ft nu times R times sine of theta, because that thing doesn't change, and that should be equal to mcgr and sine of what? Now it will become sine of 90. R and R is still gone. So Ft nu is going to be mcg sine 90 is 1 over sine of theta. This is the new one. And what was the old one, by the way? It was mg cos theta over sine theta. The old one, Ft is going to be mcg over sine theta. There was a cos theta additional thing over here. So obviously it will make sense that the Ft is more, right? Because why it is more? Because it is multiplied with cosine, and cosine is a number which is always between -1 to 1, right? The range of cosine is -1 to 1. In fact, to be more precise, I know that the angle is acute, so it's not going to be negative. It has to be between 0 and 1. So any number between 0 and 1 when multiplied to something is going to make it even smaller. So this is going to be smaller. In other words, the new tension is going to be bigger. So we are going to say that the Ft new is going to be greater than Ft old, or just Ft. This is how we solve this question. Right, let's talk about the next question. So here we are given a non-uniform disk over here, and a non-uniform disk has the mass distribution. I think the mass density is given radially and can be modeled by beta times r, where r is the radial distance from the axle and beta is in kilogram per meter cube. So this is what a linear charge density, area, surface charge density, or a volume charge density. This is not a volume charge. It won't make any sense to take the volume. This is a 2D figure anyway. This is a disk, not a sphere. So it will make sense that it is actually a surface charge density for which we have to take an area, and more justification can be given from this unit, because the unit of beta is per meter cube, right? Per meter cube, obviously kilogram per meter cube, and there is another radius which is multiplied with m, so it is kilogram per meter square. So the unit of the rho is kilogram per meter square, and per meter square obviously signify per unit area. So we are going to go at r, because we need to find the moment of inertia. We are going to go at r. We are going to take an elemental strip dr over here, dr over here, and what will be the volume, or sorry, what will be the area of this? Uh, uh, so we know that dm over dA is given by beta times r. So dm will be equal to beta r times dA. So dA is what we are interested in. But anyway, let's write the moment of inertia formula first. The moment of inertia is elemental mass dm times r square integration. dm is beta r dA r square. Beta is, what is beta? 4. 4r. And what is dA? Area will be given by 2 pi r dr. Do you understand that this is the area? I can explain it. This is a disk, right? It's like a disk, elemental disk having a width of 2r. Think about it like this. You cut it from here. You cut it from using a scissor, you cut it from here and flatten it out. So once you will flatten it out, it will look like a tube like this, right? And it will look almost like a rectangle because it's very thin. This is very thin. Now, what is the area of the rectangle? Obviously, length times width. Width, I already told you, it is dr. And what is the length? This length, don't you think, is same as the circumference of this circle or the disk? And the circumference is given by 2 pi r. So that's why the area is 2 pi r dr. I hope this makes sense. So we're going to replace the area with 2 pi r dr and r square. And all I'm going to do now is 4 times 2 is 8. 8 pi comes out, r square, 4, r raised to 4. That's what I'm getting. And now I'm going to put the bounds from 0 to the radius, which is 0.3. At this point, you can just either use a calculator or just do it manually. So it is going to be 0. I'm just gonna write one more step here for the integration. That's going to look like 8 pi times uh, r raised to 5 over 5 from 0 to 0.3. So this is approximately 0, not approximately, I think I'm getting an exact number. One second. No, approximate, obviously, because there's a pi, so how can it be exact? So approximately 0.012 up to 3 decimal places. Kilogram, I think. No, sorry, not kilogram, kilogram meter squared. That is the unit of the moment of inertia. So this is the rotational inertia or the moment of inertia of this particular disk. It was an interesting question. Finally, let's move on to, oh, that's it. So yeah, this is the moment of inertia, and I hope this makes sense. Any questions, please post it down in the comment section. So all right, so this is the question number, the last question which we have. The string connecting the disk to the pole is cut. Calculate the magnitude of the initial angular acceleration of the clay disk system. So it makes sense that if the string is cut, and this is where we have the situation. Yeah, I'm just going to borrow this now. Um, the string is cut, it means that there is no tension over here now. So the only force which is responsible for the torque is this one. So I'm going to say that torque is equal to I alpha, and torque is mcgr. We already calculated because the angle is 90, is I, which is 0.012, 0.01. In fact, this is an intermediate decimal, so I'm just going to take to maybe 22145, a little bit more precise, times alpha. So the alpha is going to be just mcgr over that thing. But here we are missing one important thing. This is not correct because the moment of inertia is of the entire system, right? Remember, the clay is still a part of it, and they are asking the moment of inertia, or sorry, the angular acceleration of the entire system. So we missed to take the the clay into consideration, and the moment of inertia of the clay is just mc times capital R square times alpha. And this will also not be, yeah, no, that's absolutely correct. So let's plug these numbers in. I think anything is getting cancelled. No, not really. So what is m sub c? Have they given m sub c? 0.6. So 0.6 multiplied with 9.8 multiplied with the radius. The radius was given as 0.3 is equal to 0.01. This is 2, 2, 1, 2, 2, 4, 5 plus mc, which is again 0.6, r is 0.3, and alpha is unknown. Let me take my calculator here. So I'm getting 26.628 kilogram. Sorry, this is alpha, right? Alpha is radian per second square. So that would be the final answer. Hope this makes sense. Any questions, please post it down in the comment section. I'll see you in the next video. Bye-bye.